Dear ladies and gentlemen, good afternoon, good morning, good evening. Welcome to our 4th International Next Facade Summit. It's a real pleasure to host you today here from our next studio by Vicona & Partners in Frankfurt. And after 3 sessions, pure live stream, and we know that 700 people are just watching us today out there, we have close to 50 people here in our next studio in Frankfurt. And it's great after 18 months of being grounded to really have a lot of faces in front of us and a lot of exchanges hopefully come. Everyone in the studio, of course, is either tested, vaccinated, or recovered. Okay? So just remind that when you see us close together, no one will get hurt just by talking to each other. The 4th event, we thought we'd do something special. Not only the hybrid event, we also thought we'd do something outstanding. Hopefully you feel it afterwards as well. Why? First of all, we have 4 famous speakers today. We had famous speakers beforehand, but today we go a little bit deeper in the dive for another theme. We have thought we go for subtitles. The first subtitle we always give is Think Globally, Build Locally. Just trying to illustrate a little bit the challenge of thinking the best thing for society, but then you are facing local building regulation, local workforce, or local communities. What is the difference like that? But we thought today we do a second subline, because it's in every discussion these days, at least in Germany, it's called sustainability. And then you will say, oh, again, greenwashing, buzzwording. But if you deep dive into the word of sustainability, sustain means maintain, preserve. Ability is a lot about competence and skills. And this is what our audience will see today from our 4 key speakers. Evan Lavelle, coming from London, working for Front. He will talk about a lot of nice projects, and he will talk about a secret project of a well-known architect grounded in London. Project is in Middle East, so look forward whether this secret project is now released today and whether you have got the permission to present it to us. The second speaker in the row will be Martin. Martin Murphy, coming from Hamburg, from Strömer Murphy Architects. He will present something. We are aluminium guys, huh? And aluminium is aluminium, it's aluminium. He will talk an 18-floor story timber structure, and about the goods and the challenges to go for that kind of new quest, because it's a complete new rethinking, and it's a lot about courage, I have heard from your side. Then we have a break. The break will take 10 minutes because the audience also wants to have a kind of walk to the fridge, getting a cup of coffee. So we have a 10 minutes break around 5 p.m. Then we come back again. We restart the session. Then Fabian is starting, Fabian Hecker from Zaha Hadid Architects in London. He will present a pretty nice project, I hope at least, Lisa Soho Beijing. It was a nice expression when I just realized the building project. It's like a couple dancing. It is maybe most important is it's an atrium close to 200 meters tall, and maybe one of the, or if the tallest atrium in the world. A dancing couple, what a kind of pretty nice thing. And this brings me to the last speaker, Dieter Brell. We have had a discussion, we had a video podcast together, and there was a citation I loved a lot, and I have never heard this expression before. Johann Wolfgang Goethe, you know them. You know him, huh? A poet, a writer. Do you know what Johann Wolfgang Goethe said about architecture? Architecture is frozen music. Dieter is combining, he's the co-founder, and he's of course also creative director of 3 Deluxe in Wiesbaden. And he will tell us a little bit about how to mix, how to fuse the idea of architecture, art, including composing architecture as if it would be music. Looking forward to your 50-50 principle. I hope you will give us a deep dive into the We the Planet project in New York, just to get it off the ground. So, all said this, I'm really happy to start that session now, together with you, going into this kind of expert level. And in addition, I must say, I'm also proud that in the audience, and you will see some of them later on, we have also the experts located. I've seen the colleagues from Ferris Architects from Barcelona. We have the COVI colleagues. We have the colleagues from Bjarke Ingels Group here. We have ACC located here. We have the colleagues from Skonto. We have the colleagues from the different parts. Inksteel is here. We have a lot of good customers coming. UPB Eile is here. We have a lot of activities showing and to share with you. And I just have to say, Left Harris from FMDC is here. Land lease, John, thanks a lot for joining us today as well. Sustainability is your hard part when we have the discussion on that. Skanska has come as well from the UK just to join us for the sustainability thing. In addition, Alutech was coming, maybe also towards you, Evan. You will be the first speaker on the row, talking about the secret project, which was secret until this morning. So let's see a little bit about that. So welcome also to the Alutech colleagues coming from Ireland, from Switzerland, and from Middle East. Thanks a lot. Said that. Thanks for all of you joining us today, and let's get ready to rumble. Evan, please take the floor. Evan Lavelle is Associate Principal at Front. Front is located not only in London, but also in New York and Hong Kong. I mean, last time when we spoke, you said we just worked on a Hong Kong project. And first we met teams-like, of course, as all of us, together with the colleagues from Middle East, because within this project, which is secret until today.
It's a lot of pressure. It's a lot of pressure.
It's a lot of pressure. We just came across. And fancy part on that, I have to tell that story. I mean, I'm a little bit older than 40, I must say. And normally all of us are a little bit older than 40. But when you talk to the team of Front, no one is older than 30. And you imagine yourself, I mean, I'm an engineer, and then young engineers are in front of you, and they want to tell you how to make unitized curtain wall, cold banded.
I'm older than 30, so.
You're older than so you're an exception, so you're close to me then.
There we go.
Yeah, and this is all about, and he will tell about Front, about the story about what is the necessity when it comes to this new design of curtain walls, and we will see more and more that the rectangular shape of the future will not be rectangular anymore. Saha did, Fabian is with us as well, he will tell us the story as well. So how can we make that kind of new ideas of the architects into build realities for us on the construction side? Evan, the floor is yours.
Okay.
Kick it.
Cool. Hi. All right. Hi, I'm Evan Lavelle. I think you already gave me an introduction. Yeah, so I'm with Front Inc. We're a kind of American-based facade consultancy. We are kind of a relatively small company, around 50 people. We're headquartered in New York, but we have kind of major offices in London and Hong Kong, with smaller offices in Seattle, San Francisco, Verona, and Seoul. And we've had the good fortune over the last actually we're 20 years old next year, of working on some really spectacular projects throughout the planet with spectacular owners, architects, contractors, engineers, of all sorts of scales, materials, locations. It's been a really kind of a wonderful experience, sort of helping sort of develop some really complex projects, beautiful little art pieces, very fast timelines, all sorts of kind of conditions that come across when making complex facades. But specifically, I want to talk today about sort of what we view as integrated design and information documentation. It's kind of a sort of a philosophical stance we've taken on how to produce facades, how to document facades, kind of how to see through facade design from a sort of ideation stage all the way through to construction and on-site. And then sort of how we kind of work through that process. So we tend to work as early as we can in the process, kind of helping owners, architects sort of technically develop their facade. And through that, over the years, we've kind of had this idea, is like, okay, well, why can't we kind of see this process through a bit further? And so we've kind of taken on the opportunities when we can, or are given to sort of engage more in the construction process and be involved in the sort of built product itself, whether through a kind of a self-performance kind of aspect, or working under a contractor, or kind of working as part of a design build team to develop facades and help deliver facades all the way through from a ideation stage through construction. And so the kind of started with this early class of projects where they're a bit smaller or they're a bit kind of smaller roles, but sort of developing this idea is like how do we take this information and produce sort of the facade, and how do we produce something that is both kind of meaningful from a philosophical standpoint, because that's kind of what I'm interested in, but also from a constructability and a sort of process standpoint. And so kind of throughout the years, we've worked through many different modeling platforms, engineering platforms, kind of sort of develop these ideas and sort of find out what are the best ways, at least for us, to sort of engage in this process. And I think I've been doing this for 15 years personally, and kind of tried just about everything in the book. And so through that, we've kind of developed a series of, I would say, workflows, and more specifically software to help kind of us engage and sort of design and document this process, but also kind of help others, I think, sort of engage as well. And we've kind of our more popular plugin we developed is called Elefront. It's available freely. It's kind of a BIM sort of BIMifies Rhino in a sense that we kind of add a lot of layers of information and metadata to Rhino models to sort of make a more useful sort of product. And the kind of the workflows that we've kind of developed and sort of try to give a moniker to is called building information generation, where we're not explicitly modeling, but we're designing a process for modeling to produce a sort of information set to make a sort of a set of documentation in the end. And that sort of led to a second class of projects, through these workflows, the Morpheus Tower, which I'll touch in very briefly with Zaha, and a couple other projects, notably the Space Needle renovation we completed recently. And this sort of kind of led to this sort of philosophy where we try to look for ways, even if we're not involved, but how do we create a bunch of information that allows the project to move forward throughout these different stages of the design process in the most coherent and consistent way. I mean, even if we are consultants, we may only be involved in the early stage, but what is a sort of a platform, what is a set of documentation, what is a set of information and design ideas that we can put forward that will enable a project to get all the way through this sort of phase? Because we're, at the end of the day, you're really interested in how does things get put together, what are the logistics as it moves through the factory, what are the logistics move through the site, and how do we sort of help through this process? So I'll touch extremely briefly and then get on to the secret project that is gives me a lot of anxiety now because it's way too important now. So this is a project we're involved in. We worked for, it's a famous project from Zaha Hadid's office, and we worked for Geotech. We were hired explicitly to help sort out the exoskeleton cladding on the center of this tower, and it's conceptually the sort of voids to go through, and there's a true actual exoskeleton. We're providing a rain screen cladding on the outside of the exoskeleton. In this project, we were providing kind of, panelization, modeling. We provided the final engineering, the final system design, final kind of LOD 400 fabrication modeling, all fabrication documents, all assembly documents, and all kind of assembly and site coordination models and documentation from a kind of a small integrated team. It's sort of one of those projects where drawings don't make any sense. There's just no reason. I think there were 3 or 4 details for the exoskeleton cladding as part of the tender package. But really the most important bits were the sort of geometric models defined by Zaha that gave the envelope as a sacred surface, a sort of structural orientation, structural model, and the specification in this case from Bureau Happold. These sort of sacred objects, you kind of put them together to sort of formulate a larger project. In this case, we were sort of, tasked with filling in the blank. So we had the structure defined by Bureau Happold. We had the envelope defined by Zaha. We just had to fill in sort of in between to make sure that it actually attached to each other. But you kind of get a sense there's an infinite number of conditions as you're kind of moving through this project. And so, we view it as a primary challenge as an author of design, as an author of a model, as an author of information. It's very easy for us to understand how this thing goes together. We've put this together, we've put the models, we put the scripts together. But the real challenge is then how to describe it down to the component level, to the object level, to give to a guy in a factory you've never met, for him to give to another guy in another factory, and so on and so forth. And next thing you know, you've got 300 people between you and putting this thing back together in the right way possible. So this is the sort of the philosophy that we try to embed in all this sort of information generation throughout the process, is how do we, tell the guy who's making this bracket to convey the next bit of information all the way through to sort of end up at the final product. And so you kind of make a model and you kind of repeat these tasks, and they're little tiny little ideas you put together, and you repeat it over and over and over again until you get sort of a model that sort of has kind of a little bit of chaos into it. And then this is now, as we know, it's good. You see this other project, a modest in terms of unique parts. I think we had, 1.2 million unique fabricated parts over across about 18,000 square meters of cladding area. You get a sense of the primary structure, a little bit chaos. I get a sense of the sort of scale of the panels as the son of workers are putting it together. But at the end of the day, for us, it was a success because the built product looks like the rendering. We had zero installation issues, zero communication issues. So for me, it was a kind of a very positive sort of reinforcement of this idea of creating a coherent set of documentation through the entire design process, which has led us to this sort of kind of new or larger class of projects which are much more complicated, much more ambitious, and even more than Morpheus. And so the projects I'm going to talk about a little bit today, it's also the first time I've ever talked about it, so it'll be a little bit rough. I apologize. Is the Plaza Towers on the left by Foreskin Partners. Another project we currently have in projects is also with Zaha's office. We're working with Far East Aluminum in Hong Kong, providing kind of design and fabrication services for a very complex tower in central Hong Kong. So Lucelle Plaza Towers is a 4-tower complex in Doha, in the Lucelle city, just north of central Doha, if anybody's familiar with it. It's two 225-meter towers and then two 306-meter towers. And there's about 16 podia buildings that kind of flank each other. So sort of central tower system that's kind of being built as part of a new city that's sort of the hub of the kind of new World Cup complex with the kind of flagship stadium, Lucelle Plaza Stadium, sitting right behind it. And this project is sort of really interesting for us because it became the sort of best sort of implementation of this idea. So we were originally hired as the consultants for Foreskin Partners, design stage from concept and scheme design. And then we're novated over to the design build architect team. So it's two different contracts. Minmac B6 is running the 2 smaller towers, and Hyundai is running the 2 larger towers, and Harim is under Hyundai, Arcadis is under V6. And then we were hired by Alutech as well to kind of see the final construction, the fabrication through all fabrication, documentation, BIM, and design. And Alutech is the facade contractor for all 4 towers. Hydro is providing the aluminum, which is about 220,000 square meters of a highly specialized custom 5754 alloy, which is unique to this project. And then Technol is providing all of the profiling and final system design for the unitized curtain wall system. So it's a huge, wonderful team. It's been a very intense process. We're basically building it in less than 2 years from start to finish. So conceptually it's a kind of a twisted tower where the top and bottom are sort of composed of these sort of 8 arc sort of geometries, and they're kind of morphing. And then there is a sort of a strip of glass that goes up and kind of spirals the tower. And then there is a large scale shading device that's providing sort of all the shading for the interior of the building. Tower meets the ground, so we're tapering kind of tapering columns, and there's an 11-meter sort of lobby space that is really spectacular curved glass. Some of the real challenges of this building, though, is that actually I'll get into the glass in a second. So basically, trying to synthesize this process, and again, I'm talking about this for the first time, so this will be really difficult. So we kind of look at sort of how do we move from these different stages of design, from an initial stage to a mid-stage and late-stage design, and how do we synthesize and sort of scale the information from an absolutely massive project and something that can be made in record time, and enable decision making at each key point to either purchase materials, do design, make all the right design decisions, and start sort of feeding the factory as quickly as possible. So for us, it starts as a sort of like a global analysis. It's sort of like a distillation of ideas. So we build a fully parametric global model of the entire tower and kind of stuff it full of as much information as possible. So we annotate every bit of geometry. It's a curve that knows, it knows where it lives in space. It knows what's next to it. It knows what systems it belongs to. It knows what angle it's coming in relative to the building, and sort of, what wind load's on it, all this kind of stuff. So you can start to peek and pull and sort of analyze it in different ways to sort of understand exactly what you're getting to and what you need to sort of get at to sort of make decisions. And so kind of initial thing is that we're having to rebuild the building to sort of prove out to everybody that we can make this, we can match the exact design intent from Foster's, and we can also make it in a sort of a manufacturable way. And so in this case, we're kind of re-optimizing the building to get the exact distribution of glass panels that were kind of tendered, but also sort of tweaking a little bit to sort of optimize for the exact manufacturing process that we want to put in play, so we can execute this as quickly as possible. In this case, which I'm going to get to very shortly, we're doing a cold bent glass for the entire tower. So there's not a single piece of flat glass. It's non-rectangular, and it's all cold bent, either from a flat panel pushed into place or a kind of a sort of molded cold bent panel. So here we're looking at different strategies for different thresholds of cold bending. So this is the amount of out of plane each panel has, and kind of looking at, hey, are we matching sort of the SD geometry or that was tendered, but also looking at the sort of economics of the glass and like how we can produce it to sort of find the right cost balance for Alutech to kind of proceed with the sort of procurement of material. In this case, again, these are all actually exactly the same model, which I think is a key point. So here we're looking at, because here we're actually talking to Technol at this point, and we're saying, okay, they're trying to understand, the complete design sort of configurations of what is every single volume going to be on the project. So we start to look at the model in various different ways, and this is measuring the angle between the panels so that we can design the dies from an early point. I think we about 3 months in the project, we had already ordered all of the dies and all the material for, or at least all the dies for about 240 stories for the tower that are completely, each panel is completely unique, and we were able to sort of give Technol that insight very early on, like here's every single condition you're going to find on the tower. We can, we're adding here in this case, mapping all the wind loads to provide all these sort of engineering optimizations, so we can find like local reinforcement if we need to, or find out what's our threshold and what conditions we need to design for. And to really save time and material, because we know we don't need to design for the high load case everywhere, but where do we need to deal with it? In this case, we're working with Hydro specifically to optimize the panel width, and we're using about a 2.6 meter wide aluminum sheet. We're buying 11.8 meters by 2.6 meter wide sheet. And trying to then anodize those sheets. So Alutech actually built, I think, is the world's largest anodizing bath as a result to make these panels. And so here we're kind of working with the whole supply chain to find exactly where we need to massage the shape of the tower, where we need to massage the shape of the cladding, such that we can, know in advance, we can procure all the material to, which thankfully because COVID, have to get as much as possible in as quickly as possible to, make sure that you could build this building in the time needed. Part of this is also sort of this sort of global rationalization. You start to tweak the floor slabs a bit. You start to tweak the overall mass of the building to kind of, in this case, because we're changing the shape of the cladding, have a response to change the shape of the building. And what's nice about this is we were able to change the shape of the building way faster than the architects could finish designing, so that we gave them the floor slabs and defining the rest of the building that was set from basically the size of the aluminum cladding, which I thought was a pretty kind of a unique experience. In this case, going back to the architects and proving out that our sort of newly optimized design is fitting within the actual sort of original tendered process. So this is sort of just overlaying all of the models and then going back to the owner architect and say, hey, we haven't changed anything, but we're kind of trying to make this thing in the sort of procurement channels that are possible within time that we have. Kind of combining everything together, you get a sort of fully rationalized, in a sense, rationalized building. full of really rich metadata that you can start pulling apart and start analyzing to get into the more greater detail. Another key thing is you're able to do early on with these sort of processes in place is that we build a fully constrained global FEA model of every single panel, of every single connection, of all the towers to provide all the reactions back to the slabs. So we're coordinating on day one with the structural engineer. I think this whole model was about like 3 weeks into the process, and we already had every single reaction to every single floor slab, and we're designing all the embeds. Very complex tower. Same model, a little bit more detail, providing all the sort of global engineering of every single panel, every single connection from the same process. This was the original, I think month 2 complete material takeoff of every single mullion, every single transom, allowed the advanced procurement of an enormous amount of material. So then we're going to get into, that's the global analysis, and you sort of dive into, okay, like how do we actually make this thing? And so I'm going to tell, I don't know how to tell the story, this is the first time I told it, but how we kind of thought about the cold building panels, and then from the glass perspective and the framing perspective, because they're two sides of the same coin. So conceptually, you have a tower, and obviously the easiest answer to do is triangulate everything, but the architect was not interested in triangulation. So then you say, okay, we have quadrilaterals, everything is 20-degree angle, it's sort of this parallelogram that's spiraling up the building. Well, how do we do that? How do we deal with that? And the kind of easy answer, the straightforward answer is, well, flat panels are cheaper, flat panels are better. However, on a sort of multi-curved surface, you have a flat panel, you start to get this popping effect. That popping effect has a huge amount of implications. One, the thermal sustainability implications are massive. You have huge thermal bridges, a lot of condensation risk. You're just going to end up with a leaky, poor-performing building. It's just not a good strategy. Secondly, it's very, very expensive to make. You already have a very complex facade. You have millions and millions of small little subparts that now you have to consider to manufacture and get right, which then will leak. So it's actually more cost-effective, more expensive to do the flat panel and said, you know what, let's just curve everything. And so actually working with Alutech early on, we took some of the direction they've had from experience at the Hamburg Tower and also in Doha. That's a completely cold bent tower, but to a little bit lesser degree. And we felt, okay, it's actually moderately reasonable to kind of propose this idea. It's not completely insane. And so, again, so at tender, we kind of had a threshold of 125 millimeters as that, okay, every contractor, let's go out, tender 125 millimeter cold bent and see what comes back. Alutech, I think, ended up tendering at 180 millimeters cold bending, which was kind of the magic threshold from both a cost perspective and a viability, because there's a lot of really tight corners at the edge into that. So cold bending itself is a fairly straightforward idea. In this case, we're taking a frame. You push a frame out of plane. You take a fat piece of glass. You put the fat piece of glass on. You push the glass down. Well, the glass actually kind of just falls into place. You put the seal on, you call it done, right? And then for the really kind of cornered edges, you traditionally would think, okay, I'll just use a cylindrical bending tempering furnace to like bend my glass. However, when you start to actually put that geometry onto the actual building, a cylinder, no matter which way you cut it, from a sheared cone or a sheared cylinder or any sort of geometric sort of shape, will not fit the sort of overall building geometry, and you have to go back and re-rationalize the building to actually make this work, which time would not allow, nor would the architect in this case. And here on the right, you can kind of see the differences of a cylindrical geometry from this sort of idealized geometry on the building. It's just too much to overcome. So in this case, we kind of did a little bit slower, but albeit a bit more expensive method of kind of cold bending. It's an SG lamination where you heat and pressure in an autoclave, take 2 pieces of glass, laminate with SGP, and you get put it on a mold, and then put it in an autoclave, and it comes out in the kind of perfect shape. But for very subtle curvature, which is nice because then you can get sort of any sort of shape out of that to a certain extent. It's a very slow process, as you can only do it in a very limited number of panels. At the end of the day, you get extremely subtle curvature out of a piece of glass using this methodology. I think working with Alutech, they've sort of found a pretty good way to sort of perfect some of these methodologies at a large scale. You kind of get a sense, this is a typical flat panel that's not curved, and you kind of get a sense of, here's some of the curvature we're going to see on the project as this sort of panels are sort of navigating. This is a curved panel that has at least one curved edge. You get a sense of, this one is, actually I don't have the out of plane on this, but it's probably about 225 millimeters out of plane, which is quite extensive. Here's this, you can see the kind of curvature on this one edge here, which kind of forces one sort of manufacturing process. A little bit more. So, in itself, this is actually a very technically challenging process because you've got to cut everything at the end of the day from a flat piece of material. Like the glass comes flat; it comes off the float line as a rectangular sheet, and you unroll that sort of curved shape. It's always kind of bigger than that flat piece. So we have to determine how big of a flat piece of glass do we need to buy, and what shape do we need to cut that flat piece of glass in to get the sort of back into the curved shape. What's tricky about sort of curved glass, especially curved glass that is non-rational in the sense, is that it has a sort of double curvature. There's a Gaussian curvature that you can kind of see in this graph. And what's particularly challenging, especially about most modern modeling environments, is that it's material agnostic. There's no intelligence in the material, in the actual model itself. It's a NURB surface. It's a mathematical construct of a surface defined by four edges. And whether that surface matches anything in reality is actually, you don't know. So we needed a way to kind of inject reality into a model to pull out what that piece of glass is that we need to cut. So in this case, we built a finite element model of every single piece of glass on the project and kind of pushed it back into its flat form. And then from that, we kind of did that a lot of times. And so sort of find out, where we have stress conditions, where do we have any deflection concerns, all this kind of stuff. But most importantly, it kind of it gives us some rules about how we can interpret the piece of glass and how we need to cut it. And you can kind of see here, it's again, we haven't made any good images yet because literally just got permission this morning to do this. But you can kind of see here, like this is the numbers on the right sort of indicate the amount of deviation from a straight line. And you can kind of see here, there's an actual subtle curvature when you unroll this piece of glass along the long edges that you actually need to cut into the flat shape such that when you put it in its curve shape, it forms into the right part. And we sort of do a poor man's machine learning through regression analysis of literally thousands of panels to sort of determine the rules in which to make that glass and make those shapes work, and apply those en masse. And at the end of the day, we end up with the two drawings. One, here's how you cut the flat piece, and here's how you put it together, and here's the CNC sort of information to do that. So you go this extremely massive, convoluted process to give a DXF file to basically a CNC machine to cut out a piece of glass. But what's really nice is then they just stick the two pieces of glass together, it goes in the right spot, and no one has to think about anything. The other side of the coin is the sort of frame design, and this is a particularly challenging aspect. Foster and Partners, like every great architect, sort of, especially for a very high-end building, we have a flush transom with a finished floor. However, there's a very particular problem with cold bent frames, is that you start to push one edge, and they're kind of rigidly connected at the corners, everything starts to twist. The mullions twist, the transoms twist, and so how do you prevent that from happening? Because there was no scenario where the architect or the owner was going to tolerate or accept a transom that is twisting on the edge, especially when your finished floor is meeting up flush with that. And so, we know we have to let the mullions twist because something needs to give, and you kind of get a sense of what's occurring on the project. So we use that original analytical model to study the sort of mullion deviation. You can see this very long tail of twisting. Most of it's 2 to 5 degrees of twist across the length. And sometimes we get up to 20 degrees of twist in a panel, which is a little excessive. But now it's sort of like, okay, how do we define a system? How do we think about a way to ensure that the transoms themselves don't twist? And there's a couple of geometric concerns, but most importantly, there's a sort of assembly and warranty concerns. So in this case, we have you put the transom in. The ideal scenario is you let the corner of the transom meet up with the bottom of the mullion. That introduces a gap, and a gap between the transom and the mullion, and that gap is right where your glazing tape goes. And the glazing tape, though, suddenly is making a jump, which then it starts to maybe void some warranties, may create some assembly conditions, and this is like kind of a sort of a no-go scenario from an assembly standpoint. And so then you said, okay, we need to find, actually the glazing tape line is going to define the overall geometry of the framing system, such that we say there's 0 or like 0.2 millimeter gap that is acceptable, and we continue that glazing line all the way around, and then re-rationalize the entire building wireframe geometry about that glazing line, such that you can have a continuous seal to set your glass down. Another kind of key aspect of this is to kind of trick the transoms into being flat when they're installed. And so what we do is we do a complex mitering of every single transom on a double angle cut, such that when you screw them together, it does a counter twist and undoes the twist that it wants to do when it's flat. And so it's kind of hard to explain. Maybe a video will show it here in a second. But here on the left, you can kind of see the traditional approach of a pre-rationalized approach of the framing system. If you did not do any of the rationalization, you would have these sort of gaps that go across where. So you kind of just micro-adjust every single transom and every single mullion, such that you kind of get this very flush surface for the glazing tape to go around, so you can not void any warranties. And you kind of get a sense here, this is the first framing system we made. It's the best video I could find on short notice, but you can kind of see as they kind of push it together, very low tech, we're trying to get it the right shape with some wooden blocks, is that you can kind of see the mullion sort of twisting out of plane as it kind of comes into line with the transom. And so the key kind of thing here is we build all of the frames in 3 dimensions in its final twisted form. We put the glass onto this final twisted frame. We add the silicone there such that there's no residual stress in the sort of secondary and the structural seal between the frame and the glass, such that when it goes into shape on the building, we're not going to have any permanent stress in the structural silicone. Here's a kind of an example of one of the more egregiously twisted panels we have. But we have roughly 80,000 square meters of glass across 13,000 panels. Every single one is unique. There's 0 repetition. They're all slightly different and slightly out of plane. There's a whole other bunch of stuff I could talk about how to actually manufacture this, how the whole workflow goes from the wireframe into the CNC machine, but another time. Here's us roughly a week ago. We've got approximately 100 stories worth of building built in about 10 months. It's Herculean efforts from everybody at all the contracting teams and all the subcontracting teams. It's been a bit of an insane ride, but here we are. Oh yeah, crazy thing, tip to tip, the panels are 7.3 meters. And sort of manufacturing and moving around and kind of trying to control a 7.3 meter cantilever panel has been an interesting challenge. So I probably went over, but. That's a secret project for you there.
Evan, thanks a lot for all your explanation. I mean, what was really true, I mean, he just got this morning the approval to present the project. It was just this morning when you received the email that you're allowed to present it, and thanks for that. I mean, it's broadcasting worldwide for the first time. Thanks that the Alutech guys are with us. So if the audience in-house today has some questions, don't hesitate to go to them. Normally, cold band is restricted to 50 mil. How did you achieve 120, 180?
So I mean that's kind of a standard rule of thumb from a design of the sealants to the sort of the primary and secondary seals, but the glass itself has no problem. Modern advances in the sort of in the kind of thermoplastic spacers and the soft spacers have that sort of ability to sort of negotiate a lot of that, sort of greater engagement with the PIB, and by eliminating all of the stress in the secondary and the structural seals, you're not inducing any permanent stress in the product itself. You can eliminate a significant number of the risks. And we had some precedents from Alutech on the Modport Tower that gave us a lot of confidence. Some of these panels have been up for over a year. We've kind of going through a lot of the cycling. More testing is underway. But for us, it's sort of, the proof is kind of in the actual product itself and watching it go through and just trying to find the right sort of ways to design the process to make it possible to work.
Exactly. And what I also found pretty interesting, you do everything. As the front is doing everything. I mean, they also do workshop drawings, they support the customer with installation drawings, and they go until the programming of the PMC centers. I mean, they support through the whole value chain of engineering, including CFD, building physics, and whatsoever. And, of course, they're young chaps, but the experience of the company is longer than 25 years. So you can trust them. Evan, thanks a lot for a very brilliant presentation. Thanks so much. Okay, thanks, Evan. The next speaker has a huge challenge in front of him. He's living in Germany, but he's a native speaker in English. And he said, "Oh, I never did an English lecture since ages." Martin, just come to us because you're the next one, Martin Murphy from Stroud Murphy Architects in Hamburg. And it will be a pretty interesting, I would say, next 25 minutes tour, because when we have started to talk about that kind of activity, we came across a pretty interesting project which is called Roots. Roots is this famous 18-story tall timber structure building. And when we started to talk about how it came that someone wants to invest into a timber structure, because he also said, I mean, it is not free of charge. It is, of course, more effort. You have to invest more. So who and which kind of investor would like to invest more into his building structure? The answer of the investor was, do you remember? You told it to me, but I guess out of your words...
Yeah, I was rather hoping you wouldn't ask me that question, actually, because it could put me in a slight predicament. The client basically said he's sick and tired of plaster facades because he'd had very bad experience with plaster facades, and he wanted to try working with timber. So that was the polite answer to that question.
That was the polite answer. You gave me the right explanation, but I will not repeat that one. But for that Lighthouse project, I mean, you also told me it's a lot about pioneering. I mean, we exchanged a little bit. Constructing in timber is Stone Age old. But to go 18 stories, it is not Stone Age. It is high-tech and it's complex. It is a lot about fire propagation. It's a lot about statics, humidity, UV stability. It is about how bearing loads and which kind of material is the right one for the right place. And in addition, Hamburg, it is seaside climate, north part of Germany, and you will have a pretty interesting session and lecture by Martin, giving us his insights on that one. And at the end, he also told me it is a project to learn about pitfalls, avoid pitfalls, learn if you stepped into a pitfall, how to come out of the pitfall. It makes you humble, and at the end of the day, you become really serious about sustainability. Okay? Not a buzzword, but do it yourself, and it is hard sometimes. Okay, Martin, all the best. Looking forward to it.
Thank you very much. Well, there's an introduction, eh? Yeah, it is interesting because, as Werner says, I've actually been here for, I don't know, close to 30 years. And even my mother says I have a German accent with my English. So you guys are all kind of native speakers. So I apologize in advance. Yeah, it is a great project, but that's the main reason why I'm here to speak about this project, Roots. But I will compare it to another project in Hamburg. Stroud Murphy and Partner, we're a group of architects in Hamburg. I arrived in Germany sort of around 1992 when there was absolutely no work in London whatsoever, surrounded by probably 1,000 expats that were all over Germany, whether Düsseldorf, Stuttgart, Munich, Berlin, and Hamburg. And I actually went there to visit for a weekend and ended up staying a good deal longer. My second attempt to actually go back to London was also reduced to staying a bit longer because I then met my partner, Jan Stürmer, in Hamburg. And Jan convinced me to stay, and You may or may not know in the 90s, Jan Sturmer was together with William Alsop. Will Alsop, London, absolute maverick of an architect. Miss him dearly, but he was with Jan a driving force in the 90s. I then worked in the firm in the 90s, and the firm has been renamed since 2002. Sturmer, Murphy and Partners. We're a group of 50 architects, different generations, different cultures, different backgrounds, all lending their part to that wonderful, diverse job we called architecture. This is where we work. It's a wonderful old building dating back to the mid-1800s in the middle of Hamburg. Although we primarily work in Hamburg, we have in the 2010, 2015, one or two international projects, but we haven't actually made a conscious decision to have satellite offices around the world. That's our central point and our heart of our operation is in Hamburg, and we're very, very happy, and I'm very happy actually that I managed to stay in Hamburg. Although I do love London, I did study there. Hamburg has been very, very kind to me, as well as Germany. What we have here, some of you may know, is the Hafen City, Hamburg. And a very courageous project, started off in 1992 with a master plan from Astok Architects out of Amsterdam. And what you see in the north part of the picture is the old structure of Hamburg. You may see the, it doesn't work because it's a plasma Bildschirm, of course. You may see the old Speicherstadt, that's the old warehouses that separated the old part of the city to the customs harbour and into the south. And all these buildings that are in the area south of the Speicher buildings, they've been built in the last 15 years. And there's a huge amount of construction, and that's only half of it. The other half of the picture is now in construction. So it's, a very, very courageous project, and through that we've been very, very fortunate to have done, I think we're now on our fifth project within the harbour city. What you may recognize also in this picture is our colleagues from Herzog de Morion, Basel. That's the affectionately known Elfi, that's the Hamburg Philharmonic. Wonderful building. Very controversial, very expensive, but now that it works, no one says anything about the controversy or about the price, which is a bit of a tip for the future generally when we have these problems. What is not in the picture, that's our colleague from London, that's David Chipperfield, that's the Elbe Tower. The Elbe Tower is, or will be, it's now groundbreaking, is 240 meters high. And until then, one of our buildings will still be the highest building in Hamburg. You can see the Elfi in the background. This was a project that we did I think we won the competition in 2011, international competition. It's, if you will, in those days, I say, because I think things have changed remarkably quickly over the last 10 years. And it's the level of construction, the typology of construction, which, if you will, was high-tech in its prefabricated elements. This is an office building on the right-hand side, a residential building on the left-hand side. And there we were using facade systems that were very traditional, if you will, 2 meters 70 by 2 stories, prefabricated, that they were all put into position on a massive reinforced concrete superstructure. So nothing unusual about that. I mean, in comparison to what Evans just showed me, this looks like a Stone Age, but it did actually require a very similar amount of computer technology, which is interesting, I must admit. The buildings itself is full ceramic, which I see here on the wall as well, and that's a material that we have used, and we thought in those days there was a certain level of sustainability in what we were doing and thinking. Werner introduced myself and our office on the basis of a project called Roots. I think over the last 3.5 years, we have, for our office, redefined what actually sustainability really means. And that's the reason I'm actually here, to tell you about this project. It really is, in comparison to what Evans was talking about, it's low-tech. But low-tech will be a part of our future without a shadow of a doubt. And it's all about sustainability, it's all about materials. At a certain point in the future, we'll be running out of sand. So we simply have to think about other materials to perform these functions. And that's the reason why, I think it was about 6 years ago, we got a call from one of our clients inquiring about would we be interested in working on a high-rise building in timber. Well, we were doing some low-rise buildings in timber, and they were difficult enough. We thought the challenge was a great one, and it certainly has been. To give you a comparison, the building that you've just seen, the high-rise, from conception to detailed drawings, we're looking at a period of about about 1.5 years. The full package of drawings to go out to tender. We've been working on this project for 3 years. We've now finished the complete Ausführungsplanung, as we call it in Germany, executive drawings. They've all been completed. Why is it taking us so long? Because this project, in its entity as a residential high-rise building, doesn't exist in Germany. And as such, a planning application would be impossible to issue. The planning authorities don't know how to give this building a green light, if you will. Now you can see I'm stumbling now, sort of moving into the German. And because of that, we had to generate all the basic data, which was a great challenge, but took us twice as long as normal. Now we have this basic data. It's great that we can use it in other projects, but the process to get there took a lot of courage by the client, because at the end of the day, it cost us also a lot of money. But we basically named this project our Pioneer Project because we learnt a lot in the process. We're talking 18 stories of massive wooden construction. We have issues in wooden construction in northern Germany where moisture is one of the biggest enemies of wood. It's not fire, interestingly enough. If you have a large cross-section of material in wood, the first 5 centimeters will burn, and then it stays like that for the next 120 minutes. Then either you evacuate the building or the sprinklers come on. So it's very similar, if you will, to a concrete or a steel building. And we have also a wooden facade for the Lighthouse building, which is an issue that we've discussed many weeks after we made this decision, many months in fact, because that's where a lot of issues get complicated in a high-rise building. You have to have a sprinkler system which is actually around the building as well. I'll show you a detail later. Also we have in Hamburg, it's rather windy, so you have to have also on this protective glass skin, what you see, also to be able to close the balconies throughout the whole building. But these glass balconies also protect the wood from ultraviolet light and also from rain. These two issues are of great importance when you're considering a wooden facade at this height. The lower level of the building is a very interesting function. The city of Hamburg found that very exciting, as we still do today. It's the exhibition or museum of nature, if you will, from Wildtierstiftung. That's, if you will, Wild Animal Trust Foundation. And their aim is to bring nature back into the city, to explain nature, and not just that it's all about, sort of the tension and activity within the city. No, that's a wonderful space that's all about wild animals and all about plants and fauna. So that is something that works very well, of course, with the idea of us using a wooden construction. This is one of the earlier sketches that we did of the building. On the right-hand side, we have social housing. On the left-hand side in the tower, it's all occupied residency. We are at the moment just going through the first basement floor. All the owner-occupied properties have been sold or reserved. The interest in this building and this typology of living has been enormous. That sort of surprised positively us all in many ways. And you can see also in the plinth of the building is where the Wildtierstiftung is also housed. This sketch basically says a lot about how much concrete we're actually using in this project, namely as little as possible. Where we do have to use it is in the basement, of course, quite sensibly, and in the plinth of the building that you see here in white. Rather like our spines, we have the core, the staircase and the lift core. That's right in the middle. That is, of course, reinforced concrete. But everything you see in brown around the massive floor slabs, the columns, the facade, the walls, it's all in wood. And that was the main aim that we had, because when we talk about projects now, we talk about carbon footprints, of course, and it's not just a fad or a word. It's something we now have to take very, very seriously. And we all talked in the 80s and 90s about how much a building costs, but now we talk about life cycle costs. So these issues are very, very important, and also what is to our clients now becoming very important, because the clients now themselves are thinking very green, because the money that they get for investment is green money. The large financial institutions want to make sure that their investment is brought into a green project. It's very, very interesting how things have actually changed. So the clients of sort of 20 years ago that really weren't very interested in anything to do with sustainable building, they're the ones now that got it biggest on their websites. We're actually very green developers or investors. So things have changed a lot, which I think is a good thing. The floor plan on the right-hand side, the social housing on the left is the tower. You can also just see the interior facade and then the glass skin, which covers all of the high-rise itself. And I'll just go into a bit more detail on the left-hand side here. You can also see the space which acts as a winter garden, if you will, and you can see the way the area, glass sliding panels above the balustrade can be moved, and also where we recess to get like 2.5 meters protected area at a height up to 18 stories. What you see in the plan here is also in brown is our wood columns as such. They basically start in the ground floor area, first floor area, with dimensions of about 80 centimeters by 20 centimeters, and then they get smaller as they go through the building. And that's something that our structural engineers, who were played a very important part in this concept, Assmann engineers from Hamburg, it was basically a journey of discovery, how this building should actually work, but also what kind of wood should we use for this building, not just the structural properties it had to have. Baubuche is beechwood, and that's the primary structural element that we have. And you can see as you go further up in the building, the cross sections actually get smaller. When I say Baubuche, we're talking about sort of a cross-ply process of bringing the thin layers of Baubuche birchwood together, and through that it achieves its strength, which is equal in many respects also to concrete. The facade, as you can see, was one of the most challenging issues that we had to protect the wood against light and against rain, and because of that you can see the sketch where the glass panels open and close. What we also see here is a very important structural element. This is what we call sort of a Zug Tragwerk, ring beam, if you will, which holds the building, if you will, in compression. We can see it here on the left-hand side. If you can imagine a wooden barrel, one of those old beer barrels, and we have the steel belts that keep it in compression. That's a very, very similar concept, if you will. Wood has the slight problem of minimum oscillation in high-rise concepts. And because of that, we have to have these steel, if you will, ring beams that keep the whole thing together. Of course, we didn't know that in those days, but now it's something that we've brought into low-rise buildings as well. You can just begin to see the floor structure. I have another drawing. We have 24 centimeters here of massive wood, and then we have a big issue from floor to floor, from apartment to apartment, of acoustic. Acoustic is the biggest issue that we had in this project. That surprises maybe a number of you, but the acoustic is cancelled out or solved when you have mass. Mass is weight. We don't want weight. We just want the necessary structural cross-section to perform the function. That is the 24 centimeters, what you see here. We're also talking 6 meters long, and 1.25 meters wide. That's the planks, if you will, the deck systems that we use. And on top of that, you have a lightweight screed, and then we have underfloor heating. In total, we were there in those days by 50 centimeters. We're now down to 45 centimeters as of the complete construction. There you see some sketch drawings of the balcony that I mentioned earlier on. And this is where we spent our time, because we had to develop the details at a very, very early phase. We had to make the planning application proofable, if you will. We had to, while we were doing pre-concept drawings, we designed all the facade elements of the building that had to do with the fire regulations, non-existent fire regulations, had to do with the acoustic, and had also to do with the facade construction. Why? Because of this building. This is our mock-up, and this mock-up basically provided us with all the information that the planning authorities needed to give this building a green light. And what we did, normally when we do mock-ups, we do mock-ups that you can see here in the facades, very aesthetical issues. No, this was purely technical. We had to find out where the building's problems were and did our details actually work. So this was it, and we had a team of scientists that went in there for basically more of like a week, and they did all took the necessary data, did all the necessary tests, acoustic from floor to floor, horizontal from one side to the other. And we mustn't forget where we are in Hamburg. As in my hometown, Liverpool, was an industrial harbour. Hamburg is still a loud, functioning industrial harbour, rather like Rotterdam. So we have a decibel source outside of 60 decibels that has to be reduced through the facade, through a Waffle system, through the Wintergarten system, down to 30 decibels. That's kind of level of sound we're talking from the outside, but as I say, going from floor to floor and horizontally was also a big issue. In any case, we gave the planning authorities the necessary information they needed to give us a green light, and that was, I think, for all of us, a very joyous day. We are now actually on, I think, about the ground floor. We'll probably be starting in about, I'd say, 6 months with the wooden construction. This sketch basically shows one of the greatest advantages with timber construction. We're able to do between 7 and 11 meters prefabricated wooden facade elements, and they get, if you're not shipped in, they get rolled in on a low loader and then put into position. So there one saves, of course, time and money, as with the previous example, you know, the ceramic tower that I showed first. The issue that we have here at the moment, especially in high-rise buildings, that wooden construction is still 8 to 12% more expensive than conventional construction. Some clients can see that this is a great barrier. Some clients say, I don't care, we want to find out what the future is about, and wood will play a part in our future. I'm absolutely convinced. Aluminium will continue to play a part in our future. You can't compare an aluminium facade wood to a wood window facade. It's just obvious there is a hybrid of thoughts going on. But still, it's a more expensive building typology to create. This diagram basically shows what I've been explaining. The grey area is the concrete core. We then have these huge deck systems of 6 meters long, 1.25 meters wide, and then you see the ring compression beam that runs all the way around the building. I won't go into too much detail, but what they are basically explaining here is the decoupling from, I'll just point out this detail, the decoupling of the sound that passes through the floor going from one apartment to the next. Those are some of the details that we had to work with our acoustic engineer as well as with Assmann, and obviously try and maximize the amount of wood in the building. There are some areas where we have used a EPE, a sort of a double T-beam, what we see here, but the reason we've done that is so we don't actually have to have a Unterzug. Helft mir jemand? Understand? Downstep beam, thanks. Appreciate that. It's actually quite embarrassing, really, isn't it? Undertook. And that basically means we have a flush underside of the apartment. I mentioned that before. I won't go into that into any great detail, but you can see that was in those days. It was actually 50 centimeters. We've now got it down to 45. This is the detail that really has caused us the greatest of issues. Because it's a lighthouse building, the client wanted to have wood on the exterior part of the building, and we supported him in that. But it is actually, if you want a issue where I would seriously think in the future, whether that's a good idea in a high-rise building or not, this is it. We have to generate a dry, if you will, sprinkler system that is positioned in the area of the balcony, which is firstly very difficult to detail, and secondly is a very expensive undertaking. I firmly believe the future of wood, although this is a project that a lot of people will notice when it's built, but I think the future of wooden buildings is not necessarily with facades, and it's not necessarily with high-rise buildings. I really believe the future of wood is up to, in Germany, it's 22 meters is classified thereafter after a high-rise building. It's anything up to that. Because then you then don't go into an area of fire regulations, which are very, very difficult to construct in wood, but you basically keep yourself in a comfort zone which is financially viable. And I think that is something that's going to happen and change in the future. We've got 2 or 3 projects at the moment that we're working on where the massive structure internally is wood, but the facades themselves are ceramic, are brickwork. There's no dogma to using another facade material. The idea is to actually create as much wood in the project as possible. It's all about the carbon footprint. That's, again, something that we had to learn. This is the low-rise building, the social housing area. As this does not have a glass skin, we have impregnated the wood. The facade wood is Lärchenholz larch, I believe, last time I looked. And they are also prefabricated elements, story high, 4 meters wide. And that we have also produced a whole range of different colors because if you look at different examples in southern Germany or in Italy, for example, this kind of pattern of process is something that looks rather beautiful. It's actually sort of silver gray. The further north you get in Europe, the darker it gets. It doesn't look that attractive. So we had to anticipate this process occurring, and therefore we actually impregnated it with this is one of the first concepts that we had, but we impregnated it with if you will, dark gray. So it would actually, if you will, grow and age with dignity. I was mesmerized what Evan was showing there before about 3D design. I think in the kind of architecture that Foster does, etc., is phenomenal, and one needs these kind of programs. But we changed probably about 7 years ago from 2D drawing from MicroStation to 3D Revit. The whole office was actually against this program. It was mutiny. But now it's the best thing that could ever happen to us. The whole communication on the level of M&P or structural engineers is phenomenal. It's quicker, it's more efficient, we find the problems a lot earlier on. Why am I saying this? Without 3D, we could not do a timber building of this complexity. We are required by pre-design to have 50% of our 1 to 5 details. That's not something we ever were used to doing. And the only way that we can do that is to work in 3D. Because we identify the problems earlier on, and we're able to solve the problems earlier on. Revit, I mean, I'm not really the computer geek myself, although I used to love MicroStation. Revit is really something that has changed the way we design and the way we think about design. But it's not an obstacle. It's a huge advantage. There is a site, as it is at the moment. We just finished the ceremony to groundbreak, if you will. We're now a good deal further than this. I think we've now got a concrete floor level, which is just about here on the ground floor. You can see the building that I mentioned very early on, intelligent quarters, we call that, and a bit further over there to the left is the Elfi. I'm very interested to see, and we all are in the office, what ground this lays for the future for wooden construction and high-rise development. But I really am passionate, and I'm very convinced that it certainly lays a lot of ground for low-rise development, which is, if you will, a lot easier, and is happening throughout Europe and Germany at a great pace. One last word. I think it's very important not just to talk about the details or the architecture, but I think if we did not have the courage of, a great consultant who worked in the fire technical issues, if we did not have the great consultants that worked in the acoustic areas, and also the structural work, then we would be at a loss. So this, as with every good project, as it should be, really clarifies the quality of teamwork more than anything else. But last but not least, without the courage that you spoke of before, Werner, of our client, to dive into this rather dark hole sort of 5 years ago, we wouldn't be where we are today. I thank you very much for listening and look forward to having your questions later.
Martin, thanks a lot to really, really motivating talk. I mean, it's still possible to innovate, to engineer in construction business. I was once in the Middle East, and we also went through a seminar, and then someone came back, and we have just chatted and said, wow, that kind of presentation was inspiring. I thought construction business is dull, but now it's fantastic. It sees something is developing further. Just a question, is it about wood or is it about carbon footprint?
They live together.
They live together?
Yeah, it's inseparable. It's about the future.
Yeah. Now you know the experience of the wood buildings. I mean, how long did it take you as a company to learn all the lessons the hard way to make this experience?
Twice as long as it should have done,
yeah.
But it's well invested time. We're now in a position to use and apply this information on other projects, and that's invaluable. I think you've got to be passionate, like a lot of colleagues are in this room, about what we do. Otherwise, you can stay in bed. You have to really want to, try and push the boundaries, and you have to find out new things. The interesting thing is, with a low-tech application, if you will. I mean, as you mentioned earlier yourself in the intro, wood is low-tech, but it's now been used in a very high-tech application, and I find that amazing. If you see the way these milled pieces of facade come off the factory line, you can compare them to Audi or Mercedes from the precision, and the tolerances are nothing to be compared with concrete. So there's a lot of advantages there, and if we can slowly but surely over the next 5 years maybe get the price down in the process,
super.
I think it has a big future.
Martin, thanks a lot for an inspiring presentation. As mentioned beforehand, we now make a 10 minutes break, so audience at home, go to the fridge, go to fill up more or less your coffee cup, whatever you would like. We also have here now the possibility to have the 10 minutes break. After the break, 10 minutes sharp, it will be 25 past 5 p.m. CET. We continue with Fabian Hecker from Zaha Hadid London. And of course, as mentioned beforehand, Dieter Brell will just give us the glimpse of architecture is frozen music. Okay, see you in 10 minutes.
Today, some of you will contribute to change the world. Outside, the world seems to stand still. Inside, it has never been as innovative as today. Rethinking for a better future. Because the world of tomorrow has already started. By 2050, 70% of the world population is expected to be living in cities and urban areas. Increasing energy consumption and carbon emissions from buildings. Our sector represents 39% of global energy-related carbon emissions. which is why investments in new buildings will have a huge impact on life quality and climate change. Drawing on our 70 years of experience, we are now developing circular aluminum products, which are helping reduce carbon emissions in the user phase. But we feel we need to go beyond. When looking at the life cycle of a building, you will find that the upfront emissions represent 1/3 of overall CO2 emissions. Our aim is to reduce by half our CO2 emissions by 2025. To achieve this goal, we are going beyond recycled low-carbon aluminum products and running every part of our business as sustainably as possible. It begins with the origin of the metal. We use hydro-Circal aluminum, which have among the lowest carbon emissions in the world. We also go beyond aluminum by working with suppliers of recycled components who share the same values. We are continuously reducing and optimizing energy consumption at our production sites by investing in cleaner, renewable energy. And we are using less packaging materials and delivering in better ways. In the end, it all starts with us. Sustainability flows through every decision we make, every action we take. But let's see the broader picture. We are going beyond ourselves to make a bigger difference. As a part of Hydro, we commit to empower 500,000 people with education by the end of 2030. We are all in this together. We know we can make a difference because we care about building a better future. Beyond tomorrow.
So, dear colleagues, welcome back. And you see it's dynamic. We really have physical people inside the room. And 10 minutes is 10 minutes, but 10 minutes when you have something to talk about is too short. Nevertheless, because of you in front of the screens and from the US via more or less the Middle East until New Zealand, we start and do our second part of the presentation path. The second part of the presentation path is going also in the way of being innovative. The question is always a little bit about Zaha Hadid. For me as an engineer, I define it organic when it comes to the shape. But at the end of the day, it's all about an explorative idea, which is the fundament of each and every single project. And I also learned it's part of the DNA of Zaha Hadid, a beloved architect, gone much too early. Fabian Hegger, Associate Director from Zaha Hadid London, is with us, and he will explain us about all these pretty nice explorative ideas in the DNA of Zaha Hadid architects, what comes out of it, and there's a lot of projects. I mean, it's the central building of BMW I have in mind. It's the Circle, Zurich Airport, which came in mind. It's a lot of nice projects. We did together also in New York one, close to the Green Line Park. Very, very nice project all together. We have seen from Evan a lot of hints about Zaha Hadid structures and projects. Fabian, come to the stage. Fabian is an architect. He studied in Aachen. But even more interesting is you are a landscape urbanist, because this you studied in London. So it is pretty interesting to understand what an architect and the landscape urbanist have in common for making building projects. This is something we really would like to look forward to. And as I mentioned beforehand, we met quite a couple of times in the past years. It's 18 months, no, it's even longer. It's close to 20 months when we met last time. We met in Riyadh at that time in Saudi. It was SAC World of Facades conference. We exchanged a little bit about the pandemic, and it will not go worse. I mean, it's just, a flu. It will pass. 20 months later, we see each other for the first time. It's great to have you here in person, flesh and bones, really to see and understand more or less what is the architecture these days when it comes to Zaha Hadid architects. The floor is yours.
Thank you very much. Thank you, Werner. Thank you very much for the introduction and for the invite as well, obviously. For this presentation. Can we switch, because that's not my presentation actually. I'd be at a loss talking about this.
Yeah. This is live, dear colleagues. Is Marco switching, or should I switch? You know that I'm so good in electronics. I'm close to 30. Yeah, but this is the good part. I mean, it's not, nothing is fake. I mean, everything is real life, and this you get from the fundament. When we met last time, we talked about the Capsark project.
Yes.
What is the status of the Capsark project?
The Capsark project is completed. I'm going to present it later on. Okay. I will present 3 projects today. Under the header of sustainability, very broadly, very generally. Mm-hmm. Capsark is completed, is in operation, and is also successful in doing what it was supposed to do. Okay,
and
here we are.
Sustainability is part of the next presentation topic.
Absolutely.
Okay.
So,
the floor is yours. Everything is prepared.
I'll start again.
Nice jiggling around. So, start.
This one, apologies. So, think globally, act locally, build locally. We've taken that as a starting point to discuss 3 different projects rather than one project. 3 different projects in different locations, very different typologies, and different conditions under which they were designed and constructed. It's the Lisa Soho project that was mentioned before in Beijing, Capsark research campus in Riyadh, Saudi Arabia, and the Forest Green Rovers football stadium in the UK. As I mentioned, it's 3 different time zones, very different conditions, and very different typologies as well. And I chose these 3 projects to talk a little bit about sustainability, not to claim that these are the most sustainable buildings or that we are in any way, shape or form very advanced with this. I think the more you dig into it, the more humble you become. What is needed and what is possible and maybe what's not possible. So this is more a snapshot of where we are, and the projects each achieved a different milestone or a different level or a different success in being sustainable. So briefly, when we talk about sustainability, we use sustainability as a term, but I think in 99% of the cases we're talking about the energy performance of the building and more concretely, obviously, about carbon emissions. We're all aware of the turbulent weather that has been occurring more increasingly over the last few years. That is without much of a doubt related to, obviously, the rise in temperatures over the last decades, which in turn most people agree is a direct correlation of the carbon emissions that have occurred since industrialization started roughly 250 years ago. So I think that now is common knowledge. Then we all know that the part that construction and buildings play in this is relatively high. It's estimated at 40% of the CO2 emissions currently occurring. So Zaha Hadid Architects was a founding member of UK Architects Declare 2019, before the pandemic, where architects came together for the first time and to formulate a common goal. It's a very broadly formulated goal, and it's probably fair to say that it wasn't really clear and probably is still not really clear how we get to where we want to or need to be. So the way I will talk about the projects and maybe try to evaluate them a little bit is this little matrix that you're all familiar with. So this is in a way is a toolkit, I guess, of how we can go about making buildings more energy efficient. We have passive measures, we have active measures, and we have the energy source that is required or that can be used to generate the energy that we will inevitably need. And for an architect's point of view, the control over these things flows away from you, so you're heavily involved, obviously, in building form, reducing loads, or the passive measures where you can influence with the design. Systems efficiency, you're handing over to the engineers. It starts to become more expensive often, and renewables or the energy source is sometimes completely out of your control. So that was the model that was used, and still is used, when we talk about the operational energy or CO2 that is generated during the operation of a building. Obviously, recently the conversation has moved on, and we've heard a lot about it already. It's the grey energy or the embodied carbon that is part of the material or part of the entire process of generating a building and using it. And the reason that has obviously come to the fore is that as buildings become more efficient operationally, the embodied energy that is in the building becomes more prominent and plays a much larger relative role in the overall budget. So, and I'm sure there are many numbers out there, this is one of them, but there are estimates that with highly efficient contemporary buildings, it can be up to 90% that the building material actually, or the impact of the building material on the overall CO2 emissions can be up to 90%. So that means that whereas previously we were thinking about the little blue element in this line there, which is the building itself and the lifetime of the building, we are now increasingly forced to think about the life cycle of the building and the whole process. And we need to learn to look at these figures, which is new for us, I have to admit. It may not be new to many people in the audience, and I've had interesting conversations over the last day or so to see where the facade industry is at, and I was very impressed, I have to say, the rigor and the depth with which this is pursued and looked at, and it's something I think we can learn from as architects. But the question for us then comes, if you look at this and you look at the figures, is obviously, do you need to start thinking about substituting materials that you're more used to using and substitute for others? We've just heard an example where timber was used for not only for the structure, but also for the facade. Or is it up to the industry to look at bringing some of these numbers down by being intelligent about the way the material is generated? It's something we're going to look at tomorrow, I think, how that can look like. So I will briefly talk about these three projects that I mentioned before. Lisa Soho is an office tower in Beijing. It was finished in 2019. 45 stories, roughly 200 meters high. It was built for Soho China. Soho China is a client that we have been working for and with for a long time. We've realized now 4 projects with them in Beijing and in Shanghai. Very similar office buildings. They are mainly for small to medium-sized companies. They are for an office building, unusually large, I find, component of communal spaces, atria, courtyards, and so on and so forth. And if you go there, there's quite a hustle and bustle. It's very lively because there's a lot of small business going on. Some of them have actually client-facing shops almost, and others are more traditional office spaces. So the communal aspect is important. The Lisa project is in a new part of a new development in Beijing, Lise Financial Business District. It's between the second and third ring in Beijing, and as I said, it's a mixed use. It's called a financial district, but it's very much a mixed use district, and it is at the junction of 2 new metro lines. But also importantly, it's the end point of a direct connection to the new Jiaxing airport of Beijing, where there's a high-speed rail connection that leads directly into the center of Lise. You can see it a bit more closely. So the project is located at the center of that new development and next to the transport center, and crucially, we'll see at the junction of these 2 metro lines. These 2 metro lines are connected via a service tunnel, and that runs directly underneath the site. And that became the factor that determined the building form very much. It's a very simple operation to come to the final result. The fact that the building was diagonally dissected by this line made us design basically 2 buildings, so there are 2 separate towers, if you like, which are then connected with each other by a common skin, and they then create this huge atrium in the center of it. The atrium itself was shaped by twisting it very much. You can see that obviously the direction of that cut that was the initial outcome of, or the initial the starting point, of the form finding was then manipulated. It was twisted in a north-south direction. The traditional plan of Beijing is a very ceremonial plan. The city is based on a north-south, east-west grid, so that's something that was referenced, and then through a series of operations that was manipulated to just generate more space and generate views to let more daylight into the heart of the building. And that's how the building looks completed. You can see these 2 towers, which are nevertheless unified into a single shape, and the spectacular atrium inside. Ground floor plan just shows what I just described. Very simple diagram, really the diagonal cut, the 2 cores into the 2 parts of the building. That's how it looks in section. 2 towers connected, typical floor plan. That's mirrored by the structure. Really, it's a hybrid system of concrete and steel. And this is how the building looks like from MEP services point of view. This project was entirely done with BIM, so it was completely modeled. All building surfaces were modeled through all levels, which gives you some very strangely beautiful and maybe also slightly dystopian-looking views. But obviously, they mirror what is the final architecture, and the two things need to go hand in hand without a doubt. This is the view up the atrium. About the facade or the envelope, as I said, it's a unifying skin, but obviously it consists of very many different facade systems because there are so many different conditions in the building. It's the office facades, it's the atrium facades, and then you have the special pieces at the base and the top as well. We've heard a lot about this from Evan, the process of optimizing the geometry. There's obviously something that needed to occur here as well. Panelization, and then trying to minimize complexity as much as possible by approximating the original shape, but with a very much a rationalized geometry, and later on panel size, and also the material choice is something that was a parameter in the process. The office, one of the elements that was developed was this facade, almost like a sawtooth facade, which has two advantages really. One is that it allows the introduction of small flaps. We've seen one earlier today, for those of you who went to the site visit, to just have a mixed mode ventilation system in the building, so there's an element of individual ventilation possible. But it also helps to negotiate the geometry, because it looks deceptively simple, but it is, as you can see, there's a slight step up the facade, and the sawtooth geometry helps to negotiate that across the entire curvature of the tower. That's a view inside and outside of the atrium. The aim was to achieve LEED Gold in the design process, and it was achieved as well. Through a series of measures, it's a fully glazed building, but it's a high performance facade. So that was one of the measures. But really the focus lay on in this case, it lay on the building systems, which were highly efficient. The way they were designed, it's the management system, everything with the help of BIM that could be. The office was able to start that process very early on and integrate it much more efficiently than with a traditional way of working. Coming back to this graphic, where does it sit in terms of energy and the tools that were used, and where is it? It is clearly maybe more traditionally it's on system efficiency. It is the operational carbon that is being optimized, less so on the build form. That has to do with the fact that we were forced, or the build form is arrived at through the site constraints. So it wasn't the most efficient way of having a building with 2 cores. So there was not much to be gained. Embodied carbon, gray energy, as I mentioned, it's a steel and concrete building predominantly. There's something that can be done about this with current technology, but that is still something that is not fully developed. It's not globally developed. It's a very regional availability that is required, for example, working with the right cements or working with reused aggregates for concrete. So that's something in this case that was just not available. What's also interesting probably is the way buildings are erected and designed. It comes down to the contractual role that you play as the architect and how much control do you actually have over that process. And building in China means that you are in a working relationship with a local design institute. They take over the design process very early on, and your influence in the later design stage is quite limited. So there's only so much you can do, and that's something that occurred here as well. The next project I'm going to was one where we had much more control during the entire process. It's a different brief, so this is CAPSAC in Riyadh. CAPSAC stands for King Abdullah Petroleum Studies and Research Center. It was built by Saudi Aramco for CAPSAC. It was a completely new research campus just outside Riyadh, consisting of 5 buildings and the common area. The aim was a LEED Platinum at that time. We started the design in 2009. It was a competition that we won. CAPSAC, or the organization behind that research center, is set up by the state, but its aim is to, as it says here, do research into policies that contribute to the most effective use of energy. And so that was one of the reasons why they asked for a LEED Platinum building, and the focus was very much on getting an energy-efficient building. That was written into the brief, and that gave the direction of travel for the entire project. This is the site in 2009. Apart from the road that leads from central Riyadh to the airport, it is effectively desert. But desert is not nothing. Desert is a space that is very complex. It's a space of flows and forces. In this case, we've singled out a few because those are the ones that we took into account when we designed the wind, the water. There's a wadi, as you can see, and the sun. Because the institution was being set up as we were designing the building, there was a certain looseness about what was to be achieved, despite the brief. And it was also not clear where this institution would go. So the degree of flexibility and openness was required. And as I said, the site didn't give us any immediate clues. There was no built context to which we could react. So it was a generic research into organizational systems that could be used. So we started with the chemical structure of oil, which led us very quickly to the hexagonal grid, which turned out to be an extremely flexible, malleable system that can be extended into a field, an endless field. So the idea of extending this into the future was something that could be achieved and retain the coherence of the overall. It also is a system through this hexagonal connecting through the connections of the hexagons. There are equal connections on all sides. This, as I said, this whole thing is malleable. It can react very smoothly to local forces or to just things that influence the geometry of the grid and take on an infinite number of shapes. So that's very interesting, as I mentioned before, because we were trying to use these forces to actually shape our building and our plan. The same operation then had to happen in the third dimension. So we had established this grid, we had established a base organizational principle, and then now we needed to look at the third dimension. So the base is a cell. It's a cell with an atrium in the center that could equally be manipulated. And the question is, how do we manipulate it and what do we want to achieve? So we looked at the vernacular in the region. And one element that was very successful for many years is the so-called wind towers, which is the principle with which the pre-air conditioning buildings were cooled. The air was drawn into these towers, pushed down into the actual spaces, and then the warm air would escape through a different opening through these towers. And so this natural flow was enforced through the buildings. So we were inspired by that and see how can that be interpreted in the contemporary way. I should say, obviously, the other aspect that's very obvious in the region is the heat and the sun is a major issue. So the buildings are extremely closed. You have hardly any openings at all to just keep the sun out. So that was the other factor that we took into account. So going back to our cell, the question is what can we do to have this shading effect to keep the cell out, yet to have enough daylight in, and how can we catch the winds to naturally cool the building as much as we can. So we did analysis about the prevailing wind directions, did CFD analysis, how to best shape the building to catch most of the wind. What helped dramatically is the fact that the prevailing winds, the cooling winds, come from the north. The sun obviously comes from the south. So that helped very much setting out the base principle. We looked at the courtyard, we looked at self-shading, optimizing the shape to get the optimum self-shading effect. And so that is the base diagram, if you like, of these cells. We then started adding one to another and started shaping the building or the entire campus with the same principle. And they need to react to each other, obviously, because you need to catch the wind for all of them. That kind of gives you this the directionality that you see there. And that led to this shape. And you can see a little bit the summary how this is working in terms of how it relates to the natural forces on the site. This is how the program is distributed inside this field. Different building types. I'm not going to go into too much detail. And this is how the final building looks. Briefly about the envelope. As I mentioned before, it needed to be a very closed envelope. Daylight is something that needs to be heavily controlled in this environment. And another aspect which was very important was a very aggressive timescale for construction. And the key in Saudi, in the Middle East, is where here we are keen to get the building watertight as soon as possible. In the region there, you need to get it sand-tight as soon as possible. So the construction method that was chosen was a sandwich, corrugated metal, a tin shell, if you like, that can be built very, very quickly, very efficiently to get the building sand-tight, and then have it clad. Another important aspect is the cavity, just to cool the surface, because it does heat up a lot despite the sun shading that you put on top. So there's a cavity, and then there's substructure and the actual GRC cladding that is put on top. As I mentioned before, to achieve the elite platinum gold and the energy efficiency, we had to work to a very low percentage of facade openings. It was a large building, you've seen that, how do you negotiate these very small openings, very few small openings with the volume? So we turned to a traditional Arabic pattern, because that allows us to kind of conceal maybe small openings in an overall pattern that helps to structure the elevations. You can see it here as very irregular shapes that then need to be panelized as well. And here you can see the construction, how the GRC panels are put onto this, what I mentioned before, the envelope out of the standing seam system. And this is how it looks. You can hardly notice the windows. You can see them because there's a certain depth, but they're integrated into the overall pattern without being noticeable as such. The courtyards themselves, because we had the self-shading, we could work with a 50% glazing which we did in a way that we actually opened it up with glass walls in the shaded areas, just to have some more generous connection to the outside. You can see it here. The roof construction is very similar to the wall construction. We have the same envelope, the cavity, the difference being that we have large glazing roof lights that we're integrating. Here you can see the construction of that, the finished product, and the view from the inside. Where possible, we did integrate photovoltaic cells on the southwestern corner of the facade to generate energy locally where we could. The important factor was a central square that connects all the 5 buildings. Now the problem is, how do you make that usable in the harsh conditions and the extreme heat? And you don't want to air condition an outside space, obviously. So what can be done to extend the season and make it usable for longer? Again, shading plays the most important role. The courtyards, the small courtyards that you've seen as part of the cells, we had solved that problem by self-shading. For the central space, we needed to devise a canopy structure, which was done with a fabric, double fabric roof. You can see the structural layer on the outside, and here the inner liner as well, the finished product that shades the central space and the roofscape at night. Yeah, looking a little bit at the sustainability credentials, if you like. As I mentioned, LEED Platinum. At that time, LEED was relatively new. It was not designed, or it was not made to be working in the desert. It was made to work in the Midwest in the US or this kind of moderate climates. So it was a challenge to get there. We did get there in the end. It's a mix of things. Again, we have very efficient building systems. It's almost a given, obviously. But then what is added in this particular project is the built form. As I mentioned before, the fact that we are using the built form to shield from the heat efficiently, effectively, and to catch the cooling winds. So that gives us a very different picture. Also, as I mentioned, PV is part of the building, but crucially, there was a huge PV farm that was set up by the client, so a lot of renewable energy was generated, which is very easy with the amount of sun there is. What is interesting about this project, and although the client was very ambitious on one hand to get this building, get the LEED Platinum and make it efficient, on the other hand, there was a hesitancy. So some of the innovations that were proposed were eventually not executed. And one example is that we proposed at the time, I said it was 2009, we proposed to use LED for the entire building. And that's something that was rejected by the client because at the time they thought the market in Saudi would not allow for that. They were afraid that if something goes wrong, they don't have locally the capacity to deal with that. So LED was not used at the time, which is something that from our point of view today sounds unbelievable. But at that time, that was some of the local concerns. And equally, we had proposed a labyrinth to pre-cool the air before it goes into the systems. There was some doubt about the functionality of that. It was built but not commissioned in the end. So, some of the battles you lose, but nevertheless, overall, it is still quite an efficient building. Final project I'm going to show is the Foreskin Rovers football stadium in Stroud, Gloucestershire, in the UK. It's a project that's not been completed yet. We won the competition in 2016. Very different context, rural England. Nice little town. The reason the project is there is that Ecotricity, which is an energy supplier in the UK, which focuses on renewable energy, is based in Stroud. They own Foreskin Rovers, the local football club, And they have a very holistic view of how they want to run their business. So it's not only about energy, it's also about traffic and food. So they wanted to have a new stadium, and the new stadium needed to fit into their agenda. But it's not only a stadium, they want to build a whole eco-campus outside town, of which the stadium is one element. You can see the site, rural site. So how to react to this site? It's a stadium of 5,000 with 5,000 seats initially that was meant to be extended, or is meant to be extended to 10,000 seats without too much impact. So how to react to this site? It is a building that wants to be very low from our point of view. It has this gentle undulating surface, and it kind of fits into this meadow landscape, but it also is one where materiality started to play a very big role. Here you can see the idea of extending the stadium is very simple. You just basically add to the upper tier here, and you get the additional seating to get from 5,000 to 10,000 seats. You don't have to do anything to the envelope or the primary structure, apart from adding this diagonal. Mentioned that before. We looked at different materials available, and that gap between engineered wood, concrete, or steel in terms of carbon emission was very big. So the choice very early on was to use wood timber for the structure. So obviously there's also something that correlates to the rural setting. We've heard a lot about the timber construction already, so I'm not going to go too much into that. Again, this is something, a project that was held up in planning for a while, but we're hopeful that this can be realized in the near future. You can see the section. Basically everything apart from the foundations is timber, the facade element, the main structure, and the roof obviously is a fabric roof, not a timber roof. But it's an all-timber building, and this is a view match day on the inside, the concourse, outside, and the players' tunnel. And you can see Foreskin Rovers already winning in the new stadium, so that's quite encouraging. Yeah, sustainability, again, as I said, it's building systems is just a given on any project. This building scores highly on renewables. Obviously, this is the client being a company that makes money out of wind energy generated by wind. But crucially, in this particular one, it is the embodied carbon and the use of timber for the primary structure. Thank you very much.
Thank you so much for your presentation. It's complete different landscape setting, complete different type of building typology, but everything is Zaha Hadid architects. I mean, in maybe 2-3 words, what is describing Zaha Hadid architecture to you? We didn't make that before, so it's...
What describes Zaha Hadid architecture? I think it is pushing the boundaries a little bit. I think we approach every project afresh. We don't have any preconceived ideas of what we want to achieve, how we want this project to look. There's obviously a certain interest in a certain fluid geometry, but it's not a given. We're not only doing these kind of projects. We do very different projects as well. So, but I think it is about pushing the boundaries and testing the limits every time. And despite the inefficiencies that are in this process, but we like the challenge. Yeah.
But it's also about the pioneering part. I mean, we have heard about that a lot of time, but try to do the utmost to develop the industry further.
Absolutely, and we are very happy to have that dialogue, and we need that dialogue, and we are totally reliant on the suppliers to be able to react to this, because there are many projects where we don't really know how we're going to achieve at the outset what we actually designed, and then it needs to be jointly developed. So, yeah.
Yeah. But I can assure you, from an engineering point of view, it's never a piece of cake to do a Sahara project. Excellent. Thank you so much for your inspiring, really good presentation. Seeing a lot of different things. Also, the cultural context is very interesting, that you play with the environment around to naturally ventilate, to light the building, not to overheat, taking all new technologies into account, but to stay minimal when it comes to the sophistication. Fabian, thank you so much.
Thank you. Thank you very much.
And now, yes, please. Yes, please. Well done. Well done. Yeah. Last but definitely not least, Dieter is coming, Dieter Brell. Dieter Brell is representing 3 Deluxe, who thinks that this is a music band. It's not the case. They're very, really famous when it comes to really have this kind of combination of architecture, also pioneering, trying to push the boundaries ahead, fusing into the art part. And I still have always the sight in mind when I now walk through the cities, architecture is frozen music. Dieter, you will just tell us a little bit about your 50-50 principle, which is pretty interesting. He will give the real explanation, but it's pretty cool. We the Planet is one of the most important themes I feel is representing the work you're doing. Also when it comes to creative design, which is the second job you have beside the first job, to be the co-founder and owner of 3 Deluxe. So this is a lot of more or less burden on your shoulders, but also gives you a lot of possibilities and freedom to express yourself. So more or less this kind of thing is very interesting. Some other things pretty nice to mention. Those who have Googled a little bit around, this is the Leonardo glass cube building, which is pretty interesting to look at, to get the feeling about your architecture and the principles behind. And I must say also pretty interesting, you bridge also everything. It's also, all of you have presented today, you just try to do something new. And you design and you support building a ship which should be CO2 neutral when it comes to the operations and hopefully also to the erection. Dieter, just inspire the whole audience and give us more or less the insights in 3 Deluxe and in your work. Okay? Welcome to the stage.
Thank you very much. Thank you much. I was just thinking, where do you have this nice poetic introduction to this quote, architecture is frozen music. I was thinking all the time, how can I have now a link to my presentation? I would try it. Yeah, okay. So thank you very much that I'm invited here, and I hope, I know after these presentations it will be really difficult for me, to be honest, because these large-scale projects I cannot deliver, and we are a small office from Wiesbaden, a small town close to Frankfurt, but I will give my best to give you some inspirations and maybe some nice ideas and entertain you a little bit with our small-scale projects. So maybe some words about 3 Deluxe, and 3 Deluxe is the initial idea of our studio. Oops. There we are. The initial idea of our studio is that we want to be an interdisciplinary design studio, and we started in the beginning with interior department and a communication design department, and then later we added department for architecture and for shipbuilding since quite a while. And so the idea of this, approach is that we always thought if many disciplines, creative disciplines working together in one space, that they can influence each other, that you can come to new ideas, that you inspire each other, that you think out of the box. And sometimes if you are not an expert, but if you are, don't know all the limitations, you find new ideas because you are, at the end, you are stupid, but maybe disruptive. And so this is the idea behind 3 Deluxe. And I want to give you some images not from the architecture, but from the other departments, that you know where we are coming from. So here are some images from our interior work. We're doing all kind of stuff, so like public spaces, airport lounges, restaurants, shops, retail, nightclubs, public spaces, and then we have started in the beginning very much with a lot of exhibitions. So we are used, to try to integrate technologies, communication technologies into spaces, and we try to do this into architecture too. We are used to deal with content, and we are used to think about, our clients, what is the idea behind them, what is corporate identity. So we are used to work with content, and our approach is very often more content and design driven and less engineer driven. So maybe this is good to know when I show you some images from our architectural projects. This is a new department we have. It's super interesting for us. We are developing cruise ships, really large ones in the moment for 10,000 people, and it's very fascinating, and because it's like big cities in a small scale built in steel. So it's super complex, and there are huge global teams working together for these very, floating cities, you can say it like this. And we are working for smaller, more expedition ships in the luxury segment. They are just sailing around Galapagos or Antarctica, so it's really nice to work in this field in the moment. And then here you can see this is a new zero-emission super yacht concept. We launched this 3 weeks ago on the Monaco Yacht Show. The idea was, to launch a concept which is pushing the boundaries in this industry too, because they are quite slow when we are talking about sustainability, and this is quite challenging for us too. And so inside this super yacht was a greenhouse that you can cultivate your own food there. So a totally different approach, and not looks totally different than the super yachts you are used to see normally in the harbor. So here's some images from our architectural output. It's more all small scale projects, but still we always try to do to bring new ideas into every project that we have. And I want to give you, before I talk about the new projects or the current projects, I want to give you for a short introduction to how we approach architecture, because as I told you, we are always more content driven and want to think about what is the building standing for, what is the idea, is it related to the client, is it related to the company. This was our first building in 2005 for the glass manufacturer Leonardo, very well known here in Germany, and we want to tell a story in the glass facade about the client and about the surrounding, the landscape. This was the interior, a very organic shaped one open space where the different departments of this company work in an open space together. The designers, the developers, and the clients are coming there, and so this is quite inspiring space for the designers. And I want to talk very shortly about the glass facade. It was in a very nice landscape situated, the building, and the client is very grounded there, and he gives there a lot of people work, and so he want to focus that the building is in the right place. And so our idea was that we want to integrate a huge artwork into the glass facade, and it was, we integrated a foil, we laminated it between the glass panes, and it was a huge artwork. It was 6 meters high and 100 meters long, this foil. And the idea was we took a lot of photos from the surroundings. They are very linked to this area in Germany with a special landscape, with a special housing. And we put this in this foil, something like a big artwork. And the interesting thing was that there was some, when you walk through the building, you see an interesting overlaying of the real landscape, which you see down there, and then the artificial landscape. So a very poetic approach, to interplay with the interplay of where is the building situated and what is the story and how is it linked with the user and the client. Here is another approach. This is a media facade in a city center here in Frankfurt, and it was here was the idea of us, the main challenge that we know many media facades, and many of them they look nice in the nighttime, and in daytime they look not so appealing. So here our approach was that in daytime, when all the people are in the city go shopping, that this kind of facade looks appealing too. And so it was a quite complex layering of glass and of different foils and then of the LED glass, so that it reminds a little bit to a fabric pattern of fashion brands which were inside the building. So this was another approach. This more a sculptural approach to a building. This was for the headquarter for the Kaffee Partner company in Osnabrück, and they want to have a strong building. They want to say we are important here in the town, and we want to be attractive and positive and dynamic, and so we designed this kind of building for them. So here you see 3 different approaches from buildings we have done in the last years, and we have the feeling, we as architects always have to find an idea. What is the idea of the building? What is the expression? What is standing behind it? Is it related to the client, to the company, to the surrounding? And we have changed our approach a little bit. We don't have the feeling that we have to look for ideas in a moment for buildings. We have the feeling that the ideas are there. You just have to work with it. And so to say it a little bit poetic, like the introduction, we can say that the briefing for the buildings is written by the poor state of our planet. To say it like this, that we have the feeling that we are facing so many global issues in the moment that we all know. I know climate change and overexploitation of nature, and then the migration issues which are resulting out of this, the social issues. So I think we have a lot of issues we are facing, and all these issues, they are popping up in our cities. The cities have to deal with all this stuff. And I think on the other side, the key for solution of all these things, or of many of these things, lies at the end in the development of our cities too. So I think the main thing what I see as a main task for all of us, not just for the architects or the building and construction company, but for everyone, is at least the transformation of our cities into a more people-friendly and sustainable places. And I think this is the major task for us, and we can see that in the pandemic, this discussion was getting to a new high level, and that many people were asking, how is the future of living? How is the future of housing? How is the future of working? How is the future of mobility? And all these things, if you put them all together, they are all related to what architects are doing and urban planning. So I think we never had such an important and relevant role in society. And so this makes our work in a moment really interesting. And so the ideas that we decided for our studio since a while, that we want to bring all our design expertise as far as we can, from our side, into this process for reshaping our cities and making them more future-proof. So this is the reason why we had in the last years some projects where we try to interconnect with all the important elements and facets that are necessary to start this process in the cities. All these projects are, at least they are not, I would not say we are perfect in sustainability, because we are not really engineers. So it's always very design-driven. Our approach is very concept-driven, and there's still a lot of, things we cannot fulfill. But this is, I want to say, just before I show these projects. And I think one of the major points in the moment, which is really in the focus in this transformation of the cities, is the public space. And this has many reasons. We know that many cities want to push out the cars, and many cities are very radical with this. In Germany, we are very careful with this. We have here all the automotive industry, so it's very difficult to be here radical in this case. But I think it's very clear that this will happen, and more streets will be car-free. And then we have to think about what do we do with this very valuable space between the buildings. And I think this is a new interesting thing, and you can ask, what has the building or the architecture, what has it to do with the public space? And I think it's the general thinking what is changing. You can see here how the streets and the cities are looking today. We have a rigid mobility grid, and everything is for the fast automotive section. And then we have a very narrow lane. This is for the pedestrians, this is for recreation. And in between the wide areas is for the buildings. And if we say in the future we will have still the fast lane, but it will be reduced, and we have some more areas which will be for, we call it the organic dynamic mobility system, for pedestrians, for the micro-mobility. We can have a totally different layout of this area. We will not have anymore the street and the boardwalk. It will change. And so this will have some effect on the building standing there. And I think you see it in many areas, in the moment, the development that the boundaries between the private and the public are dissolving more and more in many areas. And I think for new build project, it would be interesting if they can more interweave the public space with the private space. This will have enormous effect on architecture. This was a project we had 5 years ago in Lithuania. This was a project we should redesign a plaza. It was much bigger than this photo shows. And there were some buildings around this plaza. We were contracted to redesign them. This was some new build buildings, some refurbishment. And at the end, for us, the most interesting thing of this project was the plaza itself, because we were thinking some years ago that it was clear that you will have more public space in future and that the cars will vanish more and more from certain areas of the cities. And so we decided to make this project something like a blueprint how the future public space could look like if you don't have cars anymore. You can see how this space was dominated by cars, and it was not very inviting for people to stay there. And this is like the plaza looks today. And we opened this 1.5 years ago. And the idea was, at the end, that we don't have cars anymore. We have a wide, interesting, dynamic lanes for the soft mobility, for the micro-mobility, like bicycles, scooters, and all the e-gadgets that we will have in the next years, like the e-scooters. There will follow a lot of other things. And in between, there where we have the fast lanes for the micromobility, we have always the niches for the city dwellers, for recreational purpose, for sport, for communication, playgrounds. Here's an artificial creek where people can swim in the summer and have fun. And so this was the initial sketch of this plaza, that this is like you have the fast lanes for the micromobility, and in between you have, the recreational areas for the city dwellers, for the pedestrians. And on the right, you see the buildings that we have designed around the plaza, but I don't have this now in the focus for this presentation, but because there was nothing really, there was no new idea, to share in the moment. And here you see, the space for the bicycles, for the micromobility, what in future can be used by the slow autonomous e-shuttles that will come more and more, that people who are not able to ride on a bicycle, and the people who want to make more transportation or are old, that they have the possibility still to use mobility, so public shuttles. And so this image shows a little bit what we mean with the combination or the symbiosis of mobility and recreation and quality of stay in the cities. Another important point is the densification of the cities, the smart densification, the green densification, and the shared spaces. And here this is a project we are working on in the moment. This is in Manhattan. We call it the ARC. And the idea is that we want to talk about the roofs of cities, because this is something like a neglected area. Nobody has had in mind that we can use this for different things. And here you see on the left side, this is the current situation. This is Manhattan meatpacking district, and you see at least there's just gray and this absence of nature. We have unused roof surface and at least poor climate. And our new approach would be, and our client wants to have a small building, an office building, and for meetings and events. And they want to avoid soil ceiling, and they don't want to go out of the city. So the idea was to put a building on top of a warehouse in the meatpacking district, so to avoid additional soil sealing. And on the top of this building, we want to install a lush garden. And so the new approach would be for cities, that we say we can densify the cities with additional buildings on the rooftops, plus with additional greenery, and this would have an enormous effect on the city's climate. This we can think about transforming the complete roof level into a green biotope. And this would, create additional public space for recreational things. So this would be the building, or this is the building in the moment, the current situation. You have an empty roof, people are walking down in the streets. The next step would be installing a green roof, and this could be usable for the public. And now for our project, we said we lift up the garden and put a building underneath, and so we have created something like a hill or a landscape in the city. Here you see the construction is a wooden subconstructor, then we have the natural biotope on top. Then we have the facade. The facade should be activated with a lot of new technologies that can generate local energy. And then we have inside, the open multifunctional space of the company who wants to do a lot of different events and summits, and then they have one split level with their office spaces. So here you see the 3D model of Manhattan, all the flat roofs here. This is in this meatpacking area. We have flat buildings, warehouse, and we put our building on top of one building. And you see, if you get closer, you see this terraced hill, the construction of the garden with different features you can find on top. And then you see the glass facade with additional features for generating energy. This is from the side view. You see it down from the street. And if you have a look into the garden, the idea is, and this is another, our client wants this, and I think this is coming up more and more. They say a building today has to be social interactive. That you don't, as an investor, don't say, okay, I'm doing here just my project and I'm not interconnected with the neighborhood. So that if you invest in a city like New York, you have to give something back to the community. And in this case, it would be something like this garden, because people in this area, there's not much green, and they would really enjoy if they can go with their kids in this garden, can maybe grow their own food there, and enjoy the nature. And so this is the idea. In return, they have to take care of the garden, they have to maintain it, and so on. So this is a completely new approach of a building that you try to interconnect with the community, try to interconnect with the neighborhood. And this has a benefit for the quality of urban life in general. Then there are some areas, they said they want to have areas for schools, for classes, for kindergartens, that they can go there, they can learn something about, what is the ecosystem, why is the insect important for everything, and so on. So many people, many families in our big cities today, they don't have any experience what is nature at the end. And so these little biotopes could help a lot, even for educational purpose. And the client itself, they say that they don't want to use the indoor space all the time. As much as possible, they want to do their meetings outside so that they don't have to heat up in winter the building and don't have to cool it down in summer, and so save energy. And I think this is something we have seen in the pandemic, that we were used, in autumn to sit outside with a pullover in a restaurant. So at the end, sustainability it's not just something about technologies or insulation. It's at the end a very important thing is how do we behave in the buildings? Is it for us okay if we are not in a totally overheated room or in a totally cool room, like in America? We know in summer it's really cool inside, and this is definitely not necessary. This is the inside view. It's more a multifunctional room for different purposes. And here you have it integrated into the cities. And you see it in this area, there are a lot of additional rooftop buildings in the last years made, but they are all black. And this is definitely what is, as we all now know, not so a really good idea, because the city is really heating up in summer, and and they have to cool all these buildings down with a lot of additional energy. So this approach could help a little bit to improve, the city climate and that the building needs less energy. So we tried that every detail at the end of this building we have to think through that it's as sustainable as possible. If we need concrete, so that it's green concrete, so as far as is available, and we have a lot of technologies, materials integrated there. But at the end, we need more the consultancy of climate engineering specialists that they exactly tell us what is working in the moment and what not, what of the many new materials which are on the market is worth to really take serious and use them. So there are a lot of ideas, how we can integrate solar energy. And for example, this yellow foil, maybe this is something like a photovoltaic foil, but it's done out of waste wood, so something really interesting and new. And I like the yellow color very, very much. This looks quite cool for a building, for a glass. And how can we integrate wind energy into the facade without, hurting birds or whatever? So there are many ideas, but we need the experts there. And how can we integrate bioenergy, algae bioenergy, whatever? So there are so many possibilities at the end, but we have to find out what is feasible in the moment. So here you see the building integrated. And as I was talking about, the facade, what can the facade do? Here's, we are talking about smart cities always, about smart buildings, smart materials. We had opened this building in the last year in Karlsruhe. It's very close to here for the FC Ingenieure. And it's a zero energy building in operation, not in construction. So there we were not good enough, I have to admit. So it's more conventional the way we have built it. The only really interesting thing is the glass facade. And this is a new product from Merck. It's called iRise. And this facade is has a liquid crystal layer inside the glass, and it can control the heat incoming to the building without compromising the view outside. I think this is exactly these kind of smart materials that we need in the future, that the buildings are really smart, and we need more digitalization in architecture. At least if I compare to other industries, to automotive industries, or to what is a telephone looking like 100 years ago and now, in other industries, there's a huge progress, and sometimes I feel that in the building and construction industry, we are still not having the big progress that we need at the end. I know it's much more complicated and complex, but still, I think this is a very important point. The most easiest thing, for decarbonizing the cities and to enhance the quality of living is at least, if we bring really real nature back to cities. And we had here the chance 6 years ago in Sharjah city. This is part of the Dubai city cluster, huge city with not much green. And there was in the center of the lagoon in the city was this little deserted island. And we had the chance to transform it into a green garden, into a biotope. And we built some buildings on the island, built a bridge there. And you can see at the beginning, as the plants were not really growing, the big attention was, on the building. I like it still. It's a very beautiful building with this shading roof. We developed this together with Seele. It was a very complex roof, and it has the idea, of playing with the Arabic culture of ornaments, and with the idea of flying butterflies, because this is a butterfly pavilion inside there, and a little cafe. And the cafe and the inside, we try to integrate a lot of green into the interior, and a lot of daylight should come in. And so the shading roof, the golden roof, was preventing that it's heating up too much. But after now 5 years, when I go there, now what is has a big attention, and where the people go there is not because of the architecture, not because of the building, but they go there because of the biotope. And because after a few years, it has grown fantastic. all together. And the idea was in the beginning that we want just to take native plant species and not the typical decorative palm trees and stuff which you find normally in parks. But this is all the normal plants. Normally nobody takes care. And this is now really a nice biotope, an urban biotope, and many people, many families go there because they have never seen something like this before, because normally the parks look totally different. And they have a lot of birds there. They didn't know they have so many birds in the Emirates. They have more than 100 species they have seen there. And for me, it was interesting. I've never thought some years ago that in an architectural presentation I would show birds. But I think this is exactly the point. This is part of our task. I think that we have to think about how we can enhance the quality of life, and the nature plays a major role in all this. So you have here some other images. There are some art pieces in between, some pavilions. So there's really a small paradise for the people there. Now, last project, and I'm through. This is from a client in New York too. It's the We the Planet campus. We were asked from this organization that they are called We the Planet. They are organizing summits in the UN building, and the UN building was closed since 1.5 years. Now it's open. And 1 year ago, they decided that they want to have an own corporate building. And what they are doing normally, they are, this is something like an NGO, an organization. They are, taking care of, things like protection of our life on Earth, or the protection of nature, climate change, but also themes like social justice, equal opportunities. What they are doing, they're trying to bring together very wealthy people who want to invest and donate a certain amount of money to projects all over the world which are taking care of these things. And what was interesting for us, that organization like them, like We the Planet, they are not, involved in architecture, and they don't want to be involved, in something like this. They have totally different things on their agenda. And the interesting thing was that these people think that in a moment, architecture can be a really strong tool to submit ideas. And I think this is very interesting. When these people say, okay, we want to spread our ideas, and we think in a moment architecture can do this best. And this is very, very nice and interesting. And they are not stupid. I mean, behind this, there are two people who are running this organization, and behind this organization, they have a huge network of really interesting people. They have the rich families in New York behind them, and they have some polar explorers, astronauts, and people, CNN anchormen, and famous actors and musicians. So it's a really interesting network, and at the end, they all doing their business. And what I like very much, and this is a little bit the American way, and this is something I miss a little bit in Germany, they are still very idealistic in a way, And this was a sentence out of the briefing. Normally, I don't find it in Germany, things like this, written in the briefing for a building. In nature, we discover beauty, the aesthetics, and the heart of this project. So I think this is something very important for us in the next years, that we shouldn't be so rational. And here in Germany, we always say, oh no, I don't know if this works. There are so many rules and regulations, and how will it look in 20 years and still okay? And all these doubts pretend in a moment, or prevent in a moment that we can go forward. And the American attitude sometimes is more pragmatic, and they just do it. And this is something I'm missing a little bit here in Germany. Another very interesting point we brought up for this project is because we are related, with our experience with shipbuilding and living on the sea, at cities on the sea. And as we know, for all architects, in the past, always the idea of, living on a sea or installing big cities, there was always a very visionary dream in all decades for architects. And we were thinking, they want to be in Manhattan. Okay, but I mean, Manhattan is really stuffed, and what's about all the waterways there, And we just put out a map of the waterways and said, why don't we cultivate them? And we do it in a clever, smart way, without destroying the ecosystem. This could be a very new, interesting area because, as we all know, the rising of the sea levels is a big issue for many cities. And if we have something like a floating architecture, this could handle this at the end, you know. And there are some other aspects why floating architecture could be interesting. We all know how difficult it is to bring all this material, all the workers in these cities. You know, it's very, very expensive. And we know from shipbuilding, you know, they build the ships in somewhere in the countryside, you know, and in areas where it's not expensive. And then they bring the ship there where they want to operate it. And this could be for architecture a new approach, you know, if the building is built somewhere and then we bring it here and then it's in front of the skyline of New York. And so the other approach for this building, maybe I have to tell about what the briefing of the building was. At least they want to have something like, they need office space, but convention space and summit space. And part of the briefing was at least that, you know, it should be as much as possible be in harmony with nature as much as a building could be. When you build something, you always at least destroy something. But so our idea was here, you know, that we said there could be a new approach. Normally, if you build a building, it's 100% for human space, and we call it the 50-50 principle. Then in future, what if, you know, 50% of the volume is reserved to nature? And if we would follow this rule, which I know is very expensive, but if we would follow it, that would change the cityscape completely, and it would improve the city climate completely, and it would at the end make the quality of life would be enhanced enormously. And what could be interesting, you know, what kind of new typologies of architecture could evolve out of this idea. When you think that you have not just in the facade and the balconies, not just on the rooftop, but if you have, you know, in a 3D way, you have to integrate nature into a building. And so this is now our floating building. It's a floating platform, and 50% is here reserved for nature. In this case, as in the water, it's a wetland biotope. And then you have the different pavilions for different usages. You know, for multifunctional pavilions, you have a little cafe, and you have some conference and spaces, some open spaces, and it's interconnected with a walkway. And in between, you have the natural biotope. And the idea is that at least it should be public, so that people can use, you know, the open space there, and people from Manhattan can walk over there and enjoy the nature and the fresh air and the biotopes we want to install there. So we put it on one pier. There is a little connection, so you see it here now from the top view. You have this 50% is this green biotope. Then you have the pavilions with the different usages, and then you have the connected. It's connected to the pier, and on the pier, we said there must be, you know, it must be connected to the city with the electro shuttle and the bike lane, so that people can come there and walk there around. And so the client wants it. It's a totally communicative space that they want to make their exhibitions, that they want to spread at the end the ideas from their organization. They want to communicate with the people, so it should be an open space. And you see here that the roofs all have a little bit different materials or different technologies. We have natural materials like this reed roof, the brown one. We have green roofs. We have something like a roof with algae bioreactors. We have then photovoltaic on one roof, and then the white roof could be out of bioplastic, so that we try to integrate traditional material and high-tech material, so both together, I think, is and nature itself. So this is now when we integrate it into the cityscapes, this floating island. The idea was, I mean, you see it, there are a lot of additional, you know, design elements where you can say a sustainable building should better not do this, but the ideas behind that, we don't want to give up everything what we like, you know, in life just because of sustainability. And this was for the client very important, that they want to be visible, that people should talk about it, and that it looks very appealing and nice. So, and this is the reason why we said, okay, then we need a building which expresses not, you know, that everything we have to give up. You know, this is not a good perspective for our future living. And so you see here, it should be an open, inviting space so people can come there, can go there, can enjoy the nature, the different biotopes we want to install there. And there is this insect meadow, and is for bees, everything. So what today is we should install is there, and then we have there this floating mats, this wetland biotope. And then there is an open pavilion. This is for conferences, so that they say, okay, if we are talking here about climate change in this conference, it's okay if people are outside, and have a warm jacket with them. This is then you have to do this in future. And so here you see a section. So the idea is, that we everywhere on all levels we install different, things to generate energy, like a flying wind farm. Then we have water turbines. Then we have oyster farm for water treatment. And all this floating marshland biotopes, at the end, they are good for cleaning the water too. And they are generating here different biotopes on different levels. Then we have here the reed roof, which is a biotope for birds. So, and in between are the rooms where they can do their work. And so you see here the different new habitats, and you see these floating mats, very interesting material from a Dutch company. Here is another one from Denmark. They are doing a lot of interesting things with these mats. You can it's like floating ecosystems, and they have a lot of possibilities to use them everywhere to enhance the quality of life in cities, with bringing these biotopes everywhere in the rivers. And what kind of energy diversity we can bring there: wind energy, bioenergy, solar energy, water energy. What kind of materials, traditional low-tech like reed, straw, hemp, all them, or intelligent like air cleansing facades, or new high-tech materials, or bioplastic recycled materials. This should be all included. And at least, it's when you have a floating platform, you have at the end you have the idea to add more and more modules is very close. And so the idea here is to enlarge the space with more biotope, and then there's an additional jogging track for the people in the city, and then you can grow this idea, and you can say, okay, we have more and more of these islands, and then on some we add residential buildings or whatever. So our vision is, what if around Manhattan on Hudson and East River we have a second city which is on really eco-friendly city, and which could enhance the quality of Manhattan completely. So this is the idea behind this. And this is the last slide now. And it was interesting that this was just a concept, and the world it has a lot of awards since some months. It's not so long in the media, and like a World Architectural Day in the category ethics and values was a category winner. And I think it's very interesting that we have this category in architecture, and so I think this is exactly the direction which the architectural and building industry have to go in future. So thank you very much. I hope it was not too long.
Dieter, thank you so much. What is pretty interesting, at the very beginning, you might be a little bit too humble. After seeing all your works of 3D Luxe, it's definitely in the very, very good range of high architecture, and it's all about asking questions and finding solutions to complex tasks. And you have found a lot of solutions to complex tasks already. So definitely, you're humble. I like humble people. Excellent mate. Super presentation. Thanks a lot. And
Thank you very much.
Looking forward to visit the first hotel in the Manhattan area on that one. Thanks a lot, Dieter.
Thank you very much.
Maybe I'm just allow us to just get the presenters, the lecturers, the people who infused us this afternoon with excellent ideas back to stage. Also for the audience, just to clap their hands for the last time for today. To get back Fabian on stage, Martin, please, Evan. And also thanking the audience here. We had quite interesting talks today, getting more or less a lot of new ideas, pioneering. I've heard in all of these kind of presentations a lot of being humble, getting really serious on sustainability was another task. Using more or less the latest technologies to make things really happen. Don't be shy and afraid about new technologies, given by Evan a pretty interesting view on that one. Thanks a lot for the audience at home. Definitely thanks for joining us here in the next studio. Just clap the hands for an excellent afternoon, at least for me, and for you in the studio. I felt exactly the same. Well done. Thanks a lot. Yeah. Feel so. And of course, you at home, unfortunate, you have to go to your fridge once more. We have something prepared for the audience here. Of course, a lot of sparkling water, plain water, things like that. A little bit to eat here and there. So we'll just start to celebrate after 18 months of not getting into contact to really do the things once more again. And we finished the day with two things. After I stop talking, you will see Vicona Meets. It is our first video. We had a discussion. We were lucky to be with Dieter for more or less a day, getting more or less the insight about his works. He's talking about his works in that small video, giving us insights about the activities doing about. And this is the kickoff of a series where we'll have this kind of influential people with us talking about their works and how they really want to make things different for our planet, for our future. Okay? But we have now a small activity out there. Thanks a lot. Excellent afternoon. Martin, Evan, Dieter, Fabian. I go to the fridge now.
For us, it was very important to start a company which is not a typical architecture or interior studio, but that we have a different approach. And our approach was that we want to have this interdisciplinary thinking, that we are interested in all different creative industries, if it's art, if it's fashion, if it's communication design, if it's music. And this was very inspiring. And the graphic design in the 90s was a very strong and impactful business. I'm Dieter Brell. I'm co-founder and creative director of the design studio 3 Deluxe.
Discover Next, the studio for facades and design. Next is the platform for innovation in the field of building envelopes, for inspiration, information, and communication. Initiated by Vicona, with leading industry experts as Next partners. Next is a unique concept which is constantly evolving and bringing the future of cities to life.